In this problem, we have the following circuit diagram. I've already gone through it a little bit. It's pretty simple. In previous videos, linked below the like button, we've gone over section 14.2, which is low pass filter, section 14.3, which is high pass filter. And do not be confused, because in section 14.3, we can add a resistor across our voltage. However, it's not the same thing as what we have here, which is a band pass. So high pass is different. It looks something like this. And all we're doing is just not adding a resistor, but we are putting an inductor in parallel with the resistor across the voltage. Now, bandpass is what we're going to be looking at next, and this is section 14.4. We have stop bands on both sides and a pass band in the middle. So first thing we need to look at is our omega naught. It's defined as the center frequency for the pass band region, also known as resonant frequency. We have our H max, which would be the transfer function. We have our bandwidth B of the filter. It's expressed as the width of the pass band, which is the separation of the two cutoff frequencies. That's how we would find it. And then we would have our Q, which is the quality factor, and it measures how strongly the filter resonates at the center of our frequency. We have two forms. We have the series RLC circuit, and we also have what we have to the left, which is a parallel RLC circuit. And both of these will be band pass filters. So notice for the series and in parallel, we have a resistor by itself, and then we have our capacitor and our inductor either in parallel or in series with each other. And that is how we would go about solving for either one of these. The example to the left is if they're in parallel, and it's important to note that we have an equation sheet right here. And this little sheet is going to be different if our LC is in parallel or if it's in series. So if it's in series, we're going to have equations that look like this. They're going to be a little bit different than if we have it in parallel. So our parallel is right here, and this is what we're using. If it were in series, we would use these equations. They would help us out. But since it's in parallel, we will be using these, and that is how we would get these answers.